So I think the best thing I can do is help everybody here understand what AI is and what AI isn't. There's a lot of buzz in the media at the moment about artificial intelligence, and I really want to get us all on the same page. So I'm going to talk about two things. One is artificial intelligence, and the other is innovation. So I wear two hats. I have an academic background in AI. I run a master's program in applying AI to solving business problems in UCL in London, and I have a company of about 80 people who build AI solutions, particularly in retail. And I travel the world educating industry and governments and academics about the impact of these technologies on society. Okay, so AI. I want to take you through this technology stack. And the first question, this is going to be very interactive, so you're going to have to warm up. The first question I want to ask everybody is, what is data? We've heard the word data a lot. I'm sure that you use data in your own businesses, but can anybody tell me what data is? Anybody? Data comes from the Latin word datum, which means given things. It's just stuff. It's the fabric of our universe. It's not until you give something context does it become information. So if I say to you 210280, that's data. If I say it's a date of birth, then it becomes information. So what does this say? What does this probably say? Huh? Okay, good. What does this probably say? Okay, good. There's one guy over here that's helping. So you can see that the light that's entering your eyes, the stuff in the middle is the same light, same data, but you're giving a different meaning based on its context. All right, what does this say? What does this say? It's not a trick question. John read the letter to Mary, or John read the letter to Mary. So picture in your head, John read the letter to Mary. Picture in your mind, John read that. What picture do you have in your head? Maybe you have a picture of a man reading a letter out loud to Mary. Or maybe you have a picture of a man reading a letter that was sent to somebody called Mary. So this piece of data here can be interpreted in two different ways. Actually, it can be interpreted up to 13 different ways. So if I say to you, the letter is the name of a book, and I say, John read the letter to Mary. Or if I said that the name of the book was called The Letter to Mary, and I say, John read the letter to Mary. Or if I said these were 4 words on a piece of paper, the letter to Mary, and I say, John read the letter to Mary. This piece of data here can be interpreted in many different ways, and we will all go away and have a picture in our head of what we think is a true interpretation, and actually it could be interpreted in many, many different ways. So one of the biggest challenges we have in computer science is taking this messy world of stuff, all of this light and sound and videos and images, and trying to figure out what does it actually mean. Okay, so imagine I give you a spreadsheet. Okay, and in that spreadsheet it has 3 columns. It has a column of the date, it has a column of the temperature on that date, and it has a column of the number of ice creams that I sold on that date. So date, temperature, ice cream sales. What do you do with that information? Huh? What do you do with that information? Huh? You might want to try and find some patterns. All right? You might draw a graph to try and find some patterns. So if I drew a graph, and along the bottom here I had the number of the temperature, and here I have the number of ice cream sales, what would my graph look like? Huh? Okay, so I kind of see a trend going upwards, right? This is I'd organize some information to help me find some patterns. I can do something really cool now. I can do a thing called linear regression. I can put a line through it. And now what I have is I have predictive power. I can say tomorrow is 22 degrees outside, and I can predict how many ice creams I'm going to sell. I can use this model of the world, and I can implement it in a factory. And if the factory knows that it's 22 degrees outside tomorrow, then I'm going to manufacture a certain number of ice creams to sell those ice creams. And I would argue that we use machine learning to find patterns to help us know things about the world. But knowing something doesn't mean that we understand it. So can anybody tell me why we sell more ice creams when it's hot outside? So it's hot outside. What's the first thing that happens? I'm inside. It's hot outside. What's the first thing that happens? It's not a trick question. Huh? Maybe I go outside. And then what happens? Huh? I get too hot, yes, and then what happens? Huh? Thirsty, I want to cool myself down. How do I cool myself down? I buy an ice cream. What do I do with the ice cream? Put it down my pants. What do I do with ice cream? I eat it. And why does eating an ice cream cool me down? Because it's called thermodynamics. Okay, so to expect a computer to understand that narrative, to expect a computer to understand that humans like to go outside, we like to be warm, we get too warm, and we can cool ourselves down in many different ways, is a big ask. So what we're doing at the moment is we're using machine learning and these types of fancy techniques to find patterns in data, but we want to work with the domain experts to understand what those patterns mean, to interpret them. So for example, if tomorrow is the hottest day ever, according to my model, according to the model of the world that I've generated from my data, what will happen? I'm going to manufacture lots and lots of ice creams. That's what my model of the world says. But if tomorrow is the hottest day ever, what will actually happen? Nobody will go outside. Right? So the model of my world is incorrect. Okay, so maybe my factory will manufacture lots of ice creams. I'll send all of the ice creams out there into the world, but I'll sell none. The model of the world looks more like this. Okay, and this is the iterative approach to try and get our systems as close to understanding the world as possible. Because what we want to do is we want to understand so that we can ultimately make good decisions. And it seems like every single technology company at the moment that touches parts of this technology stack is calling themselves an AI company. Anybody that touches data at the moment calls themselves an AI company, and it's not true. When it comes to making decisions based on our understanding, it turns out that humans are actually really, really bad at making decisions. I'll come on to AI in a moment, but I'm going to ask you a few maths questions, okay? I know it's still early, but your job is to answer these maths questions as fast as possible. Because if your competitor answers them faster than you, then they'll take your market. So the first question is this. The combined price of a bat and a ball is $1.10. The bat is $1 more than the ball. How much is the ball? 10 cents? Okay, so most of you probably think it's 10 cents. It's not 10 cents. The bat is $1.05. The ball is 5 cents. The combined price is $1.10. The bat is $1 more than the ball. So you have cognitive biases. You've got biases in your brain that will answer these questions wrong. And I can give you thousands of these questions, and you will get them wrong. Humans are actually pretty rubbish at making these decisions. Let me give you another example. So here, imagine, I don't know, I've got 5 staff members. And I know everything about these staff members. I know whether they can swim or fly, or I know what gender they are. And your job is to figure out, how do I line up these staff members? How do I orientate them to satisfy these rules? I won't ask you to do this, but can anybody tell me how many possible orientations there are of these 5 Pokemon? So here I'm looking at one orientation. If I swap 2 Pokemon around, I've got another orientation. Can anybody tell me how many possible orientations I have? Yeah, 5 times 4 times 3 times 2 times 1. So there's 120 possible orientations of those 5 Pokemon. Many of them won't satisfy these rules. Many of them will, but only one will be the best one. Okay, let's make it a little bit more complicated. I've got 15 staff members. Can anybody tell me how many possible combinations, orientations there are of these 15 staff members? Roughly? So 15 times 14 times 13 times 12. So it's over 1 trillion possible combinations, of which many will satisfy these rules, many won't satisfy these rules, but only one will be the best one. Now, industry have problems not of this size, but of this size. So here are 500 Pokemon. Can anybody tell me how many possible orientations there are of these 500 Pokemon? Okay, so it's a big number. That's the size of the number. And just to put this into context, that's how many atoms there are in the universe. So these are what are called resource allocation problems, and they exist throughout all of industry. And it turns out that humans are usually solving these problems, and we're solving them very, very badly. And there's a reason why I want to tell you this. And actually, okay, let me give you another example. So imagine you're a retailer, and you need to deliver packages, in this case, to 24 different locations in London. So I've got 24 customers that I need to deliver packages to. We could probably sit here and we could probably draw quite a nice route around these 24 points, the route that's going to save us the most amount of time. Can anybody tell me how long it'll take a computer to come up with the best route? The one that will save the most amount of petrol? Anybody? Roughly? 5 minutes? Sorry, 20 billion years. So we've played this game already. If you put 24 times 23 times 22 times 21 into your calculator, you get this number. And if you have a computer that can look at 1 million routes a second, it would take longer than the age of the universe to figure out what the shortest path is around those 24 points. And if I add another point to the map, I've now got 25 times 20 billion years. 400 billion years. If I add another point to the map, I've got 26 times 400 billion years. And just to put this into context, one of my clients is a large retailer in the UK. They're delivering to 100,000 points on a map every single day. 100,000, not 24. And they have milliseconds between each customer coming in to optimize stuff in the background. And the key word here is optimization. So at the moment, everybody's excited about AI and machine learning. And what we're seeing are technologies that can find patterns in data almost now as good as humans. So I could take a picture of all of you, and I can see who are males and who are females and who are happy and who are sad. Okay, this is what machine learning is good at, and this is what humans are quite good at as well, but we're not good at optimizing. We're not good at making decisions. So when I build systems for organizations, you need to be able to get access to the data. And by the way, the definition of big data is more data than you can process on a single machine. So there was some debate about that, but big data is just more data than you can process on a single machine. You want to use machine learning to find patterns from that data, and then you want to use optimization technologies to be able to make good decisions. But this is still not AI. But most companies are still calling themselves an AI. The best definition of intelligence I've ever found is this one. Goal-directed adaptive behavior. Goal-directed adaptive behavior. If your system is not adapting itself in production without a human, it's not AI. There's a definition of stupidity which I like, which is doing the same thing over and over again and expecting a different answer. Okay, so most systems in production, you give it some data, it will put it through some sort of model, make a decision. Tomorrow, if you give it the same data, it'll go through the same model, make the same decision. If your system is not adapting itself, changing to an ever-changing world, then it's not AI. Okay? What typically happens at the moment is organizations will build systems or buy systems off the shelf, they'll run them for maybe years or several months, and then they'll replace those systems. But if you can get your system to adapt itself, then I would argue that it's AI. This really is the real paradigm of AI. Systems that can adapt in milliseconds instead of weeks and years. Okay, so innovation. So my expectation is that over the coming decade, all of these technologies will probably become commoditized. So all of you will have access to these AI technologies, even technologies that can adapt themselves. The real battleground is going to be for talent. How do I attract people and how do I motivate people to use these technologies to build innovations for my organization? And one of the best books, actually, I've ever read on motivation is by Dan Pink. He said there are three things that motivate people: autonomy, mastery, and purpose. Autonomy is giving people freedom to do whatever they want. Mastery is giving them the ability to become really good at what they want. And purpose is giving them some hire to align themselves with. So if you want to generate innovations within your organization, if you want to be the Amazons and these other organizations, you need to inspire and motivate your talent. And in fact, the best definition of intelligence that I've ever found is actually by Steve Jobs. He said that innovation is creativity that ships. And I often ask people, what is the most important word in that definition? So who thinks it's creativity? Now, you're all in industry, so who thinks it ships? I think it's the word that. So that is the process of taking an idea and getting it to the point where somebody's willing to buy that thing from you. And one of the biggest challenges we have is how do we shorten that lifespan? How do we get these ideas to market as fast as possible? And I think there's a wake-up call that needs to be had by lots of companies. This is a very simple representation, but if on one dimension we have how sexy is your industry, and on the other dimension is how interesting or challenging are your problems, if you are not sexy and you don't have interesting problems, then you are not going to attract talent. If you're sexy and you've got lots of problems, then you'll attract talent and they'll stay with you. And if you're in the other two quadrants, you'll attract talent, but they'll churn. They'll leave you after 18 months, 2 years, and that can be even more dangerous to your organization than not attracting talent at all. And there's another dimension to this, which is once you've attracted talent, how do you get that talent to thrive within your organization? And just to give you some ideas, my company has about 80 people. We don't have any managers, we don't have any KPIs, we don't have any hierarchies. We let everybody set their own salary. And we don't have any concept of holidays. We enable our employees to be free, and we use AI to reorganize our company, to restructure our organization. So artificial intelligence isn't going to be used just to try and figure out how do I sell more stuff to customers. It's going to be used to figure out how do I motivate and empower my employees. Because actually that's going to be your differentiator. So I would argue that we could probably take any problem that exists in the world, and we can build an AI solution that outperforms humans at almost anything. If we really put our minds to it, if this was the bounds of human endeavor, we can build individual systems that can outperform humans at almost anything. And there's this drive towards what is called AGI, Artificial General Intelligence, where instead of building individual systems that's quite inefficient, the question is, can we build a system that can do a range of things better than humans? Not just one thing, not just deliver packages, not just allocate staff, but can we build a system that could do a range of things better than a human? And if we take this to its extreme, then over the coming decades, we will build an AI that's smarter than us in every single possible way. We will build one brain that can do everything better than every human on the planet. And most scholars think that this is going to happen in about the middle of our century, and it's actually humanity's biggest existential threat, because we do not know what will happen when we build a superintelligence. And it's something that keeps me awake at night. Actually, some scholars, people like Elon Musk, think that this has already happened and that we're living in a simulation created by a superintelligence in a different universe, but that's probably for later on. Before we build superintelligence, we are building systems that are having to make ethical decisions, that are having to make decisions about that impact our lives. This is called the trolley problem. Imagine you're in your driverless car, and the car, in front of you, you have a kid, and to the right, you have two adults, and to the left, you have a cliff. And the car can't stop. Who does the car kill? So who will kill the kid? I would kill the kid. Who would kill the adults? Who would kill you? It's a hard question. What's really interesting is for 2,000 years, philosophers have been deciding about what is the right thing to do in these circumstances. And what's interesting is we're now having to build them into systems. Let me ask you one more question. Imagine you have a burning building, and in the burning building there's a crying baby and a suitcase with $100 million. Which do you save if you can only save one? Most people will say, I'll save the burning baby, right? But some people will say, wait a minute, I can save loads more babies with $100 million. Loads more babies. So these are really interesting ethical decisions that we're having to build into these systems. All right, so I'm really interested in a concept called ethical verification, which is, can we build systems that are actually going to make good decisions for humans? And I would argue that organizations, yes, to be successful, you need to be customer-centric. You need to make sure that what you're building is for your customer. But I would also argue that companies need to be purposeful. If you want to be able to attract the best talent, to help you build innovations, to use these amazing technologies, your organization is going to have a purpose. And the purpose of my company is to enable people to do what they want. Some people are concerned that over the coming decades, AI, artificial intelligence, and these technologies are going to free more and more of us from our jobs. And we might end up having some economic or social unrest because people don't have any work. And this is something that concerns me. It's something that concerns the employees in my company. And we're trying to build technologies in the background that tries to make that world a better place. This is our purpose, and this is why we attract top talent. And I think that is it.